Hey guys, Mr. T here, another video. This is a little more complicated one because it's getting into some more hard maths, but luckily for you, the calculator does most of the work here. So this is about finding probabilities or proportions using a graphics calculator. So the last little video was about finding proportions of the data in a normally distributed set of data using the chart on page 280. So using the known proportions of a normal distribution on 280, it's only useful if you want to know the percentage or proportion or probability of data between whole standard deviations from the mean. So what we looked at last time was a normal distribution. We knew the mean and the standard deviations, 1, 2, 3 above and 3 below it. And we used the percentages, the known percentages on the chart on page 280 to find those. So let's go with the example again, a sample with a mean of 486, so 486 is in the middle, and a standard deviation of 6, so one standard deviation to the right would be 492, 498, 504, standard deviation less would be 480, 474, 468. So easy enough to find the percentage of data between values that sit on these. These are whole standard deviations away, and if your question asks you specifically between these numbers, then it's going to be easy. You just look at the chart. So the example, I think, or this might be slightly different, we used in the last video was what percentage of data lies between 474 and 492. Well, you would have looked at the chart and you would have seen, well, this section is 34.14%. This is also 34.13. This is 13.59, 13.59, 2.15, 2.15, and 0.13. That's what we read off the chart. And if we were looking for the probability or the proportion of data between 474 and 492, well, we're looking here and here. Well, it's going to be 13.59 plus 34.13 plus the other 34.13%. Just grab a calculator. You would have just added those all up because conveniently these two numbers are all whole standard deviations away from the mean. 13.59 plus 34.13 plus 34.13 again. So that's telling me 81.85% of the data is going to lie in this space here, from that line to that line, which makes sense. That's the majority of the normal distribution curve. So yeah, 81.85%. But what if you're interested in values that don't sit exactly in a whole standard deviation of the mean? So what if the percentage of data, you're interested in the percentage of data that lies between 482 and 490? So what if you're interested in the data laying between here and here? Oh, can't draw straight. Say 490 grams and 482 grams. Those don't sit exactly on a standard deviation. What do? You can't do it manually. You can't use the chart because you can't just have a chart for every single value between 486 and 492. So you're going to use the NormalCDF function of the graphics calculator. So how do you access that? You press second and vars, select the second option in the list, NormalCDF, and then you'll see the following appear. And so what is this? After lower is asking where you, for the lower value. So this is where you put the lower value you're interested in. So in this case, you would put 482. Upper is where you put the upper value you're interested in. So the upper limit, that's where you would put 490. And then this, the mu character, this is where you put the mean. And this sign here, I don't remember what it's called, that's where you put the standard deviation of your data set. Paste isn't an option that you need to enter anything. That's just what you select and press enter on when you've entered all your information. So, unfortunately I can't show you the calculator screen because this is on the iPad, but I can show you what I'm going to put in. So for data that's normally distributed with a mean of 486 and a standard deviation of 6, what proportion of the data would be between 482 and 490 grams? So going on with that example. So just like the instructions I just gave you, you would go second, vars, select normal CDF, and in lower. So this is what you would put as an answer to your question. You would put your graphics calculator entries. Lower is going to be 482 because that's the lower value I'm interested in. Upper is going to be 490. The mean is 486 as given by the question. Standard deviation is 6. Then you scroll down. Once you've entered all that, you press enter on paste. It appears on your screen. You press enter again. So then you would write your answer as PR of 482 is less than X is less than 490. So this thing in brackets that you're saying is the proportion of the data, which is represented by X, between 482 and 490 is going to be, and once I've pressed enter, it comes to 0.495 to 3 decimal places. So what does that mean? Times by 149.5% of data lies between 482 grams and 490 grams. Does that sort of make sense? Well, if you look at this graph here, this is what I marked between 482 and 490. That is not the majority of the data. It's quite a lot of it, but it's not the majority, so that tends to make sense. Okay, that's what the calculator spits out. It says 49.5% of the data is between those two numbers. Okay, the only other thing that you're going to need to deal with is greater than or less than. Sometimes you're going to be asked for the proportion of data greater than or less than a number, not between. So previously, it's asked for between 482 and 490. Well, in this case, you might be asked, what's the proportion of the data that's going to be greater than n? So here, this is what the question might look like. What's the proportion of the data, x, greater than n? What is that saying on the normal distribution? It's saying if say n was here, if that was the number that you're interested in, it's saying what percentage is represented by all of this that I've coloured in. That goes on forever. So what probability or percentage is that? So in this case, the upper value, you don't have an upper value. You're not given it because you're not given 482 to 490. You're just given anything greater than n. So all of this greater than n. So the upper value is infinitely in the positive direction. So upper is like infinity this way. Okay? So for our purposes, we can't actually put infinity in the graphics calculator in Normal CDF. What you need to do is you need to enter the largest number possible, which is E99 as your upper value. How do you access E? It'll be second and the comma button. So as an example as what your calculator would look like, it would be Normal CDF, lower. This is for greater than, right? Lower is going to be n because that's the lowest number that you're interested in. Upper is going to be E99, and then your mean is the mean given in the question. That is the standard deviation, and then you paste, okay? Then you'll get your answer. In the other case that you might encounter, the probability is less than n. What is that saying? It's saying that, let's use the same n. If n was here, you're interested in the probability or the percentage of all of the data that lies below the number n. So all of this that I've badly coloured in. So in this case, the lower value is infinitely in the negative direction. So that saying lower is infinity in the left direction, so negative infinity. Because on a number line, negative numbers are on the left, okay? So for our purposes on the graphics calculator, like before, we can't write infinity. You need to enter the smallest number possible or the lowest number or the furthest away in the negative direction as possible. So in this case, you're not going to put E99, you're going to put negative E99 as your lower value. So just remember, it's going to be the negative sign at the bottom, the bottom button there. So the negative sign in brackets. And then just a reminder, you access E with a second and the comma button. So as an example for how you would answer a question like that, your normal CDF would look like this. Your lower is negative infinity, so you're going to put in negative E99 for the lower. Upper is going to be, well, the upper limit of numbers you're interested in is here. You're not interested in anything on this side of n, so the upper limit is going to be whatever n is, and then the mean is whatever is in the question, and this is the standard deviation. Then you press enter on paste, and then you press enter again, and then it'll tell you the percentage of the data as a decimal. So hopefully that helps you out. This is a little more complicated stuff. It requires you to think about what you're actually being asked in the question and then plug it into the calculator. So keep in mind the idea of these normal distributions. If you're told the data is normally distributed, the data is going to form a shape like that. And if it's asking for PR, the probability or the proportion, it's asking you how many percent of the data lies between two numbers or above a number or below a number, that sort of thing. And so if your numbers don't sit exactly on a standard deviation, then you have to use the graphics calculator, and the function that you use is NormalCDF. You access that with second vars, I think, second vars, and then you select the second option, not NormalCDF. Alright, so hopefully that does help you out, and I'll see you in the next video.